Azure Container Apps is a managed service that simplifies the deployment and operation of containers in the Azure ecosystem. Unlike Azure Container Instances, Container Apps provide a platform for building microservices and serverless applications with event-driven scaling. This makes them well-suited for modern architectures where rapid deployment and minimal infrastructure management are crucial. By leveraging Kubernetes behind the scenes, Azure Container Apps reduce administrative tasks related to cluster provisioning and configuration. They also integrate seamlessly with Azure Container Registry, allowing developers to store and pull container images securely. This approach advances the capabilities explored in previous modules on container registries and basic container deployments. Azure Container Apps fit into the broader Azure compute ecosystem by providing a dynamic, serverless environment for containers. They supplement traditional services like Azure Virtual Machines and Azure Container Instances by offering simpler scaling and a managed runtime. When designing solutions, organizations can leverage container apps to handle event-driven workloads, background processing, or microservices that must scale rapidly based on real-time telemetry. This complements the more persistent infrastructure provided by Azure VMs or the flexible orchestration from Kubernetes. By offloading certain architectural responsibilities, teams can focus on developing and refining containers rather than worrying about the underlying cluster configurations. Azure Container Apps provide key benefits that enhance developer productivity and operational efficiency. First, they offer built-in automatic scaling, enabling workloads to adapt quickly when demand fluctuates. Second, they support networking constructs like ingress and traffic splitting without requiring complex Kubernetes setup. Third, they offer integrated revision management, allowing rollbacks and version-based routing. Fourth, Azure Container Apps are event-driven by design, meaning they integrate natively with Azure Event Hubs or Azure Functions for asynchronous workflows. Finally, they provide a consistent, managed platform that handles routine updates and maintenance activities, enabling developers to focus on delivering high-quality, containerized applications. An Azure Container Apps environment is the foundational resource for grouping and managing one or more container apps. Creating an environment involves specifying a region, networking configurations, and optional log analytics settings. Once the environment is established, administrators can deploy multiple container apps into the same space while sharing resources and networking rules. This isolated environment architecture reduces the complexity found in traditional Kubernetes clusters and simplifies the operational overhead. An environment also supports multi-container deployments, letting developers define specialized containers for tasks like sidecar monitoring or data processing, while preserving a cohesive, secure application boundary. Networking in Azure Container Apps is designed to streamline external access and service-to-service communication. By default, an app can be configured with an ingress endpoint, enabling HTTP or HTTPS traffic to reach containers directly. This eliminates the need for complex load balancer deployments, as routing is managed by the platform. For internal traffic, container apps in the same environment can communicate securely without exposing endpoints publicly. In more advanced scenarios, custom domains and certificates can be integrated for secure TLS connections. Additionally, compatibility with Azure Virtual Networks allows teams to connect container apps with private resources or on-premises environments. When deploying Azure Container Apps, teams can apply infrastructure as code practices using bicep files. This approach aligns with earlier modules on bicep and ARM templates, allowing for consistent and repeatable deployments. A typical bicep file includes definitions for the container apps environment, the container app itself, and related networking or logging settings. Teams specify the container image source, resource limits, scaling configurations, and any environment variables within the file. Once complete, the bicep template can be deployed via Azure CLI or Azure PowerShell. This automated process reduces human error, improves efficiency, and integrates seamlessly into continuous integration and delivery pipelines. One of the core benefits of Azure Container Apps is the concept of revisions. which track changes to an app's configuration or container image. Each new revision represents a distinct snapshot, allowing teams to perform rollbacks if a deployment encounters issues. Revisions also enable traffic splitting, letting organizations gradually shift a percentage of requests to the latest revision, minimizing disruption in production. Additionally, developers can test new features under controlled conditions by directing only a small subset of traffic to a fresh revision. This approach enhances the reliability of ongoing deployments and ensures that any performance or functional issues are contained. Azure Container Apps use a flexible scale model based on events and metrics, similar to the Azure Functions consumption plan. Teams define scaling rules, such as CPU usage or message queue depth, which trigger the platform to adjust the number of container instances automatically. Container apps leverage Kubernetes-based horizontal pod autoscaler (HPA) concepts behind the scenes, but hide the complexity for operators. Developers can specify minimum and maximum instance counts, ensuring cost-effectiveness while maintaining availability. Scaling can also align with schedule-based rules or custom events, enabling targeted expansions during known traffic spikes and quick reductions when the demand subsides. Azure Container Apps support integration with various Azure services to build more robust and event-driven solutions. By connecting with Azure Event Grid, developers can handle real-time notifications from other Azure resources, triggering container apps to process data or run specific workflows. Integration with Azure Service Bus enables asynchronous message handling, improving the resiliency of composite applications. Container apps can also log output to Azure Log Analytics, permitting in-depth performance monitoring and security analysis. Additionally, developers can utilize managed identities to simplify authentication to services like Azure Key Vault. These built-in features streamline connectivity, reducing the need for extensive custom code. When operating Azure Container Apps, several considerations can enhance reliability and management. First, implementing clear naming conventions for container apps environments and resources improves maintainability. Second, leveraging resource limits and requests helps avoid resource conflicts among containers. Third, combining logging and performance metrics with Azure Monitor provides centralized visibility into app behavior. Fourth, applying revision-based deployment strategies and traffic splitting can mitigate risk during updates. Fifth, securing container images in Azure Container Registry ensures compliance with enterprise standards. Lastly, scheduling periodic validations of scaling rules and environment configurations supports ongoing platform optimization, aligning application performance with business needs.